Okay, this is 6.2 representing functions. So first we're going to look at situations. That's what we're going to focus on today, where I'm going to tell you a situation in words and we're going to transform that into a couple different ways. For our first one, Janice plans to enroll in a Spanish class at a language school. She has to pay a registration fee of $100 plus $20 for each hour-long lesson she takes. So what would the input be? The input would be, you would probably be figuring out how many hours she took it. So what you would put in her number of hours. So we're going to say her input is going to be hours. How many hours she's planning on taking a lesson, how many lessons, hour-long lessons. Okay? And the output would be, well, if I put in 1 hour, I could figure out how much I have to pay or my total cost or dollars. Okay? So I'm going to put in a certain number of hours. I'm going to just take guesses, and then I'm going to calculate the cost that goes with that. So write a verbal description of this scenario. So what I'm looking for there is kind of just to get you starting to talk about the math you would be doing. So you would say, maybe you would say something like $100, or let me actually change that. You'd probably say $20 times the amount of hours plus $100. Because I would, if I was 1 hour, I'd multiply by 20 times 1. If it were 2, 20 times 2, and then I always have to add the 100 at the end. Then write an algebraic expression for it. And what they're looking for there is, I'm going to kind of write it two ways. I'm going to say to get the cost, I would do 20 times the number of hours plus 100. Do you see how I kind of took the words and turned them into math symbols? Well, the cost we said was our output, and that goes always with y. Your output is always with y. 20x, x is standing for hours, plus 100. So you took a verbal scenario and you turned it into an algebraic equation. So this is it verbally, where you kind of took all your information and said in words what you were going to do, and then you use that to make your equation. Y equals 20x plus 100. Then it says create a table for the scenario. So again, the top is going to be your input, and the bottom was your output, which we said was cost or dollars. So we could put in 0, 1, 2, 3, maybe 4. Oh, I gotta get that thing off. Okay, now for the cost here, this would be 20 times 0, which would equal $100. Over here, I would do 20, I would multiply that by 1, and I'd still have to add my 100. So that would give me $120. Over here, 20 times 2 plus 100. That would equal 20 times 2 is 40. 40 plus 100 is $140. You'll see, we did these before, guys. This is the, plugging numbers into an XY equation. We're still doing that. Okay, so I filled in my table. Now, I'm not going to require that you have the work shown at each step. If you had 100, 120, 140, 160, 180, that works out just fine. I wanted to show the work for you. Then we're going to say graph the scenario. Now, I have some of these labeled. I probably shouldn't have had them labeled that way. So I'm going to, when we put a squiggle here, that just means like we're skip counting. And I'm going to make this 100, 110, 120. So you can see the squiggle means I went from 0 to 100, 130, and so on. I think you get the idea of how I changed my y's. Because look at my numbers over here. If I counted by ones, I have to go up 100. Oh, that's a pain. So now I'm going to plot my points. I had over 0, up 100. My input was 0, my output was 100. When I input 1, I got back 120. When I input 2, I got back 140. 3 was 160. And 4 was 180. And again, if you need me to, I don't know if you need me to fill them all in. You can fill them in on your paper. Okay? So you can see I had an input, I had an output, because is this scenario a relation? Yes, this scenario is a relation because I have an input and I have an output. I have a mapping of two numbers. So this would be, yes, I have an input and an output. Okay, is this scenario a function? Well, you guys can come back to here and you know your vertical line test. So if you run your vertical line test, every time I drop a vertical line, I only hit 1 point. So your answer is here, yes. You could say it passes the vertical line test. Each input okay, so it is a function. A linear function is a function where all of the points lie on the same line. And by definition in math, a line doesn't curve. So when you go back and look at our graph, is this a linear function? Yes. Look, you could draw a straight line through those. So we would say here, yes, we could draw a line to connect our points. Okay, now remember the line can't curve. It would have to be, if it looks like it can't curve, it has to go up the same amount every time. So we're going to do another one here. A tank contains 8 gallons of water. Water is then pumped into the tank at a rate of 2 gallons per minute. So you start with 8 and it's pumping in, so you're going to get more into it. So I have 8 plus 2 times the number of minutes. And then I can change that into 8 plus 2 times the minutes equals the gallons. Okay, so after 1 minute, I'd have 10 gallons. After 2 minutes, I'd have 2 times 2 is 4, or now add the 8 that were already there, 12 gallons. And then you can change this by just replacing, sorry. Okay, so here's our equation. Y equals 2x plus 8. I'm going to take the number of minutes, I'm going to multiply it by 2, and then add the 8 gallons that were already there. That'll give me the total number of gallons in the tank. Okay, so again, my input is minutes. My output is gallons. You can pick 0. Did it again. One, 2, 3, 4. And again, I'm using that equation that I had because that makes it easier. So 2 times 0 minutes plus 8 equals 8. 2 times 1 minute plus 8 equals 10. That linear equation, that y equals mx plus b type thing we just did, is helping us to make this easier. So you'll see the part I'm changing is the x. I keep plugging that in. So there's my table of values. I have an input and an output, and an output. So 0, 8, 1, 10, 2, 12, 3, 14, and 4, 16. And then I can graph those. Okay, so I have 0, 8. So I'll, So there's 0, 8. I would have 1, 10, 2, 12, 3, probably 14 would be up here. And is this an example of a linear function? Your answer is going to be yes. Okay, because look, you could draw a line, straight line through those. There's a constant increase, the same amount of increase between the points. Now, I'd like you to work through the next example yourself. So push pause, work through, then just come back and I'm going to really quickly give you the answers. Okay, for the answers to this, it would be 6 times the number of games is the cost. So that gives me 6 times the number of games, which would be my input, get x equals y. So there's your written algebraic expression. You can make a table. So I have games, I have cost, 0, 1, 2, 3. Okay, 6 times 0 gives me 0. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. I'm constantly taking the number of games and multiplying them by 6. This is a relation because I have an input and an output. So my points are 0, 0, 1, 6, 2, 12, 3, 18, and 4, 24. Again, you might want to change this so it's not counting by the same thing because we have to go up to 24. So you might even want to count by 6s. So let's make this 6, 12, 18, 24. You could count by whatever you'd like, if you'd like to count by 5s or something too. So at 0, I had 6. Oh, I'm sorry, 0 was 0. Let's erase that. So it's 0, no games, no money. 1 was $6, 2 was 12, 3 was 18, 4 was 24. Okay, and you can see these would all lie on a line. Okay, so what you're working on for this day is taking a verbal description of something, and from the words you should be able to write an equation, create a table, and create a graph. So that's what this lesson was about. You took the words, you created the equation, you were able to create a table, and you were able to create a graph.